Hello, everyone. Welcome to my session on how your coding harness can become your also autonomous security harness. So this talk about closing the loop on vulnerability management in the post-Mythos era, and we'll go through ways to protect yourself in the post-Mythos world, essentially, yourself and your product and your company. My name is Igor. I'm head of security at Lovable. I previously I was at Sana, which was acquired by Workday. It's like Swedish AI company. I was at Telavox, the digital telco with million subscribers across Europe. I was a digital route. I also spent quite some years as infrastructure security engineering manager at Shopify, living in Montreal. Overall, I have around 15 years in engineering and security experience. And of course, like past 2-3 years, it's been very, very agentic, very, very focused on the most modern challenges of security. And in my role at Lovable, I do manage all aspects of security. But again, I also manage a team of engineering security, which essentially gave the idea to this topic, which we've been engaging with, and I wanted to share more of our developments in the area. And also I think this is something that the realization we realized, okay, this thing can become a thing for most companies out there, right? So essentially we started with the problem space. So we were losing our sleep as 250 plus CISOs that signed the very famous CISO letter after Mythos model was released. We were all very worried. So when attackers will have very advanced AI, what will happen to defenders, right? So how can we protect our systems, our companies, and how can we match that super advanced capability? So essentially in this new post-Mythos landscape, and Mythos, I use Mythos here interchangeably, right? It can be any advanced AI. Adversaries need to find just one entry, right? One even single low severity bug they can use, they can get in, and then they can start exploring internally, and they find another bug and then another, and then suddenly like one of those chain of low severity bugs turns into full takeover, right? However, defenders are outnumbered, and defenders need to cover much wider ground. So defenders need to cover every possible issue across a much larger surface. So the problem is the asymmetry of this equation. So attackers need to find one thing, defenders need to protect everything. And we already seen teams struggling to keep up with the inflow of AI-generated findings. We're seeing the attacks increasing on our own systems, and we are starting to think, okay, like it's not an option to do nothing, right? So it is not an option to just rely on existing systems, methods, and defenses. Even if they hold today, which they do, tomorrow they will not be enough just because attackers will have advanced AI, that's a fact. And defenders need some sort of step-level change to match the elevated attacker capabilities. And probably all of you have seen zero-day clock, proposed by Sergey App, or formerly SysDig. So essentially in the past 8 years, the exploitation time from CVE being published to actively exploited in the wild went from 2.3 years to essentially 9 hours. It's crazy. So from years to hours, and is projected to reach minutes by 2027. So we all know about some advanced attackers just running their own AIs against disclosures, immediately producing POCs, and immediately starting to attack. So advanced capability is here. Human level is not enough anymore, right? We need to fight advanced AI with advanced AI. So, however, like we were focusing in my team, we were thinking hard about what do we have that attackers don't? And defenders do have some sort of home field advantage. So defenders do have things that attackers cannot get access to, at least until they break into the company. So defenders do have a context, right? They do have why the certain system has been built. They have that knowledge. They have the knowledge of internal tooling. They have access to internal tooling. They can use a lot of machinery that has been built to support development and support products in the company. They have access to design docs and RFCs. They have access to internal Slack, chat, discussions, messages. Also, of course, they have a source code of their application. They have runtime logs of like you can send a request, you can get a response in the real time with the debug mode activated. Essentially, you can get quite a lot of information that attackers never will be able to get. And you can use that information for your own good. So the proposal of this talk, or the idea, is that you can build the autonomous security harness with very little effort, and I will prove it to you by the end of this call, on the same agent loop you already run for coding. And it does not even have to be a super sophisticated agent loop. You can take any tool you have, from Claude Code to Lovable to something else, and you can make it into something that finds you pretty reliably security bugs and fixes them. So the idea is that you just need to connect the thing to all possible context sources you have, and you need to instruct your agent to use them properly, right? And then you run two loops side by side. You run the attack loop that hunts chains of weaknesses, so essentially does what the attacker would do, but with lots of access to internal details. And then you have a triage loop that fixes whatever was found. So the architecture is rather straightforward. So at the center you have the orchestrator loop. So the orchestrator agent, your main agent. So it does work in 6 stages. So we do discovery, threat modeling, attack synthesis, then running the attack, then reflecting on what was found, and then triage and fixing. So all that is powered by the context you provide, the context that attackers don't have access to, and that's something that should give you the advantage, should give you time to fix before the attackers breaking into your system. So now we can look into more details of this loop. Pretty much here is how I see it. And what's interesting here, in addition to the previous architecture slide, I just showed that first, of course, we run the discovery. We then understand the threat model, the business model. Then we come up with the ideas of attacks, and then we run the attacks, right? And the attack runs against the live instance of the application and records our observations. And then the loop essentially iterates between attack attempt and reflection until all the attack attempts proposed in the sweep are exhausted. And after they're exhausted, the context is compressed, and then you try again, unless you reach the absolute end of possible depth for your product or the company. So essentially, in the first stage, we start with the discovery, right? Discovery means that you need first to build a knowledge base of facts about your system you're trying to protect. So this should be done on those resources that attackers have very little access to, hopefully none, such as documentation, code, RFCs, tickets, Slack, you name it. So the more you bring, the better it could become, as long as you can instruct your agents to turn that information into facts. So one good way is just to store that data in the working dir of your harness, or as rows in the database. So you have like a database of base of knowledge about your application, and then you instruct to capture anything useful that can come in handy when attacking the system. So another thing is that this discovery results, the database of facts can be persisted between the runs, so that you after every run it becomes more informative and more full. So and then example facts. I mean, this is very short, quick, like small examples in a way, but of course it can be much more exhaustive and it could be quite advanced. I will show you how those facts can look like a bit later. Right, and then we go into a threat modeling stage where, we call it threat modeling. You can call it business logic modeling, or you can decide how to build that skill. And also, each of these stages can be turned into a good skill. Now, all these coding agents, they operate with the concept of skills. So this is a good idea for a skill or sub-agent. So essentially, you take facts, and then you build, okay, what does the system do? What can possibly go wrong? What are the trust boundaries, crown jewels? Who's using the system? Who's attacking the system? And then one thing that we found quite useful is building the attack tree. So the attack tree, you instruct the skill to build the attack tree for everything discovered so far. So essentially, based on the reality, based on facts, based on the business and threat model, what would attacker want to try or like do in a given system state to achieve their goals. Again, stored in the same folder where the harness lives and can be reused or re-updated after every run. Then the next step is actually preparing the attack. We call it attack synthesis, but it's based on those attack modeling, threat model and the attack tree, and based on facts, the agent can combine them into a hypothesis. So if this is happening, then probably some attack is possible, right? And then it comes up with a plan how to get there, the success criteria, how to exploit it, and some stopping conditions and fallback, like what to do if that doesn't work. And you can also instruct that skill to be a bit like persistent, right? Not just give up after first fallback, but like keep trying different things, keep reiterating, because within the same hypothesis and within the same attack tree, within the same fact space, there could be different ways to achieve this goal. So yeah, once agent comes up with the attack plan, then, well, you need to instruct it to execute the attempt, and executing the attempt is actually the real hacking, right? So you do have, because most likely, and this is the key here, right? So your coding harness most likely already has access to your development or staging environment. It's live, there is a database behind it, so it's perfect for executing the attack. So you just instruct it to use that environment, to send the payload, to watch the logs, and record what happens, right? And then if the success criteria is met for that attack, well, then you succeeded, and then you write that observation, then vulnerability is confirmed, essentially. And then it shows up as a file in that harness folder. Then most of the attempts will end up with nothing, right? If you have a reasonably protected app or system or company, nothing, like, most of the things, 99 out of 100 will end up with nothing. But again, there could be learnings, there could be low severity findings. The agent needs to decide what to do next. And one thing that works well is trying to encourage the agent to chain the facts, the interesting observations it discovered into the next iterations of sweeping against the same system. So essentially, most likely you will go into this middle box here, same target, new angle, or you can decide, you can give it opportunity to pivot. So essentially, these three steps, three potential outcomes is important to explain in your skill to the agent, so the agent knows what to do next. But the idea is that either it keeps attacking using the attack plans it has, or it goes onto another sweep where it updates the facts, probably takes a bit different scope of the application to test, and then tries again, builds a new attack tree, builds a new attack path, builds a new attack proposal, and then starts doing it again. Right, and then another stage before going into the triage, explanation of that loop is, well, Anthropic calls it dreaming, right? But essentially it's compressing the context, because, imagine running this thing for 3 days. It will come up with 1 million of facts. It will come up with quite a lot of potential attack vectors, and it will become very slow and very disorganized, right? So on every loop, every step of this loop, we need to do some sort of context compressions. So we would discard dead end attempts, nothing that led to anything interesting in terms of findings, and just summarize it so that the important information shows on top. Again, this is this 6 stages, essentially it's 6 skills you can implement, and then you can chain them into the main agent. And then you can run the triage loop. It can run in the in parallel. So you don't even have to wait for the first 3-day loop to be over. It can already start picking up findings from your loop, the first loop, the discovery loop, and it can start attempting to fix, validating the fix. Again, in the production environment, you have access to running instance of the application. So your coding agent is perfectly set to create that patch, apply the patch, and then run the QA on top of it. And then at the end of the day, you end up with the report that opens PR, explains what it fixed, and even it can tag right humans as reviewers. So this is fully autonomous. You can just if you nail it down, the implementation, if you really achieve good precision on this, you can run it on full autopilot, and it would just keep creating, keep finding issues, keep bringing relevant code owners into the loop, and your vulnerability management would be fully agentic, which is incredible. So, and what's interesting, we found a lot of similarities between the attack loop and QA loop in terms of capabilities it needs to succeed, right? So both path to harm and path to break, they work best if they have a lot of context. And base models, they're not great at security design by default. So be mindful, be patient with designing the QA loop, but overall providing as much access to your context, and then providing some primitives that summarize that context, that put it into perspective for the AI to take it and base its fixes on it. It's important, right? Then the exploit and regression is just literally the opposites of the same. It's one is the way into the system, the other is preventing it. And live behavior probing versus live QA, same thing. It's just confirming that something is present or not present. So essentially, you end up the same loop serves two purposes. Again, my key insight here is that the harness you need already exists. Just augment it with skills or sub agents. Use your favorite coding agent. And what's interesting, it works for both, very well-known development coding agents like Claude and OpenAI Codex and Cursor, but it also works in Lovable, that is targeting 99% builders, as long as you bring enough context into it and connect valid code and live instance of the application to your loop. And then the hard part here is not the agent itself, right? It's bringing the right context, doing the handovers, running against live environments. So if you succeed at that, essentially you get the initial implementation of that continuously running vulnerability program. Now, this is the call to action to all of you. Do it today. Point your coding harness at your own product before someone else does, before someone else points Mythos or post-Mythos model. You have cards to play, use them. And now I wanted to have a bit of fun, and I wanted to try, can I build this in Lovable? Of course, I'm interested party here. We tried to do it in Lovable, and I think we succeeded. So I wanted to show you how it looked and what it found in the example of the application. So for instance, this was the application. It's deliberately vulnerable, and we run the same loop as I described against the application. It completed in 10 minutes. Honestly, it was shockingly fast. And then it ran 100 iterations. So essentially, it created, first it created facts. You can see some facts. It's already been a bit pruned because some vulnerabilities have been fixed. But essentially, you can see that it collects the information about the system. Then it did build the attack tree. I also asked I asked the system to create a nice visualization for me. So essentially, this is the attack tree, automatically created, and then you can see that how it leads to different attack goals that were essentially found to be vulnerability paths. So for instance, it was identified that lifecycle and approval integrity of the application is lacking, and different issues are possible, essentially. So from this attack attack path, it went and it started attacking the application. You can see the sweep log, what was doing on each sweep, which areas it was targeting. And then it did find quite a few interesting things. So this is how it formulated it. Like, this is, you can put it in front of your development team and you can ask them to fix it, or you can add it to your automated QA loop and it would fix it as well, right? So this is the vulnerability description. And then, as you can see, it also not just provided the proof or reproduction steps, it also, like, this issue, this finding has already been fixed. So it did QA on it, it did regression test, and it did even put some residual risk or accepted risk notes. So if we look here in the like application chat, it says that, okay, it hit sweep 100, it found a bunch of things, and it fixed 10 out of 11 findings and one partially fixed. So yeah, that's the beauty of it. So you don't need the super advanced harness or AI talent in-house. You can just attach it to whatever you have, and then it just creates skills for doing those loops. And you're pretty much done. So essentially, you just need these 6 skills, and you need to orchestrate this iteration logic. And again, this is just one implementation of it. It can be different. It can be more advanced. It can use sub-agents, as I mentioned. It can use more advanced QA or like attack attempts. But even with this, it managed to find all the deliberately put bugs in the application and even fix 10 out of 11 of such bugs. So yeah, essentially that was my talk. There was a bit of a message here: point your coding harness at your own product before someone else does. So do that, and yeah, good luck. Thank you.